Everyone, I am going to yap away today about carbon. So, big topic. Get ready to jump in. It should be a good one. So, carbon comes from greenhouse gas sources. Um, we have this whole list here of industry and transport and buildings and electricity, and these are the main focuses of how we can make these strategies to reduce carbon. Electricity, let's slap a solar panel on everything. Transport, ride your bike to work. Industry, let's evaluate supply chains and how uh, material A makes it to material B to be converted into a random object that we provides a good and service and we purchase it. Buildings, how we can make everything LEED certified and make our passive homes, and these are all great. These need to happen. Transport, we need to cut down on fossil fuel consumption. But is that the solution to climate change? Most certainly not. Putting a solar panel on everything, is that the solution to climate change? Probably not. But should it happen all over the place? Yeah, definitely. I like to focus on this little green area, which is food, agriculture, and land use. Specifically soil science, regenerative agriculture has become this like totally meaningless and greenwash term, but hopefully we can, find something else before these like large industries like Cargill or Monsanto catch on to these things and totally water them down into something that they're not. I mean, you can go on Amazon right now and filter your purchases by regenerative, but like, what does that actually mean? Well, regenerative means that at a basic level, it's just practices that improve soil health and don't deplete the biosphere while they're being produced. And we live in this economy right now where we think that the economy is at odds with nature, that businesses and services need to destroy nature in order to create a profit, which is actually false, because you don't have to be a tree hugger to understand this. Essentially, things that are carbon intensive are also cost intensive. And if you can reduce carbon, you can reduce cost. We don't need to be purchasing things from halfway around the world and shipping them all over the place when we can get them from, within our state or region or country. So this is kind of like a similar breakdown of what we were just looking at. We have electricity generation, materials, buildings and cities, transportation, all have these little sections here, and the size of the section denotes the amount of carbon that can be reduced in these areas. So for example, buildings and cities, we can do direct heating or increase our insulation in buildings, which are great. LEED certification, huge impacts, super cool. Will it solve climate change? Probably not. Electricity generation, slap a solar panel on everything, or wind turbines. The problem with these areas, though, is say we wanted to meet our 2050 net zero goals. In these sectors of material use or buildings or transportation, we'd have to make a ton of electric cars. Electricity generation, we'd have to create all these wind turbines that require concrete, precious metals, fiberglass. So to meet our 2050 net zero goals, we'd have to increase plastic production 5 times, increase concrete production by 3 or 4 times, extract precious metals at a way higher rate than we currently do. My dog is clanking around in the background. But what's really cool here is, food, like I said before, if we can just reduce our food waste, that has huge impacts. Let me underline this. Reduce food waste. Huge impacts. Plant-rich diet, huge impacts. And in developed nations, most of our food gets wasted after we've already purchased it. So come on, guys, just eat your food. But I think what's really cool here is this women and girls one, which is like way overlooked. So we've got here educating girls and family planning. This is a huge section. Really, like at the outset, you wouldn't have even thought of that as a climate solution, but it is. In developing nations, women are pulled out of schools for a multitude of reasons, whether it be religious or cultural reasons. And when women are less educated statistically around the world, they wind up having like 5 children, as opposed to educated women have like 1.5 on average. So, like educating women and girls has these huge implications that, I guess I didn't really think of, and I thought it was kind of cool. And then here's another little breakdown, this little pie chart, which kind of shows like, okay, the number one solution for mitigating climate change. Nobody really saw this one coming, but it's refrigeration. So we have like CFCs and HFCs and all of these high intensity chemicals that are in coolant systems, these gases that wind up leaking when we either don't service our refrigerators or we throw them out and they end up in a landfill and they get crushed, and these gases are released into the atmosphere. But then we have this section here of like food waste and plant-rich diet, which has, they're kind of in the same realm. So if you put those two together, it's the greatest solution. Actually, I believe family planning and educating girls actually accounts for more than reducing food waste and plant-rich diet put together. So I really like to focus on food waste and soil health and intact ecosystems, regenerative agriculture, and I think that it has huge implications that are widely overlooked. But to go back to carbon, like check out this little picture here. So this is a core sample taken in Greenland at the ice sheets, and there's like 2 miles of ice sheets that go all the way down to the bedrock, and they take these huge core samples, and there's little bubbles inside of the core sample that have all these gases in them that date back 400,000 years. So we can go in there and we can measure, how much methane was in the air 400,000 years ago, or 200,000 years ago, or 100,000 years ago, or how much carbon was in the atmosphere, and nitrous oxide, or any of these other greenhouse gas chemicals. And when we look at it on a chart, we can see like, okay, 350,000 years ago, we were at almost 300 parts per million. 125,000 years ago, we were about the same range, a little lower. And at this point, it was 1 degree C higher temperature on average than we currently have. And there was like lions roaming in Germany and dolphins swimming up to the Arctic Circle, and we had all of these equator-based mammals and that were traveling way higher than they normally do because the temperature was so much higher. And then we hit the Industrial Revolution right here, and holy crap, what happened? We're all the way up to like basically 407 parts per million carbon in the atmosphere. And I mean, the core samples show this. This is undeniable fact. So anybody that wants to deny climate change here is tripping. But this is just carbon. There's other chemicals in the atmosphere too. There's other gases. So when we look at methane, nitrous oxide, sulfur hexafluoride, CFCs, HFCs, refrigerants, the actual level here is like 490 parts per million. It's probably a lot higher than that, in fact. These are conservative estimates. So when I mentioned that there's like other gases, right? This is what a lot of people don't realize, is that when we measure carbon in the atmosphere, we're also measuring methane, we're measuring nitrous oxide, we're measuring HFCs, CFCs, and a whole array of other chemicals that are then converted into metric tons of CO2. This is how it's done by the IUCN and these international scientists that measure greenhouse gas emissions and do the reporting. So we see all these numbers here. What do they mean? Carbon dioxide 1. This is 1 molecule of carbon dioxide and how much heat it traps. Well, if you have 1 molecule of methane, 1 molecule of methane traps 28 times more CO2 than 1 molecule of carbon. That means that the complexity of the molecular compound traps that much more heat. Everything traps heat. This is thermodynamics. This is how energy is measured, is in heat, in calories. And then, we jump down to nitrous oxide, 265 times more potent greenhouse gas than carbon. The global warming potential, GWP is what it's called, is 265 times greater for nitrous oxide than it is for carbon dioxide. And then HFCs, CFCs, these are all refrigerants. And that's why refrigerants are like such a huge topic here, is because, look at this. We're going from 780 ranging all the way up to over 10,000 times the global warming potential for 1 molecule of this in comparison to carbon dioxide. Sulfur hexafluoride, 23,500 times the global warming potential of 1 carbon molecule. And a lot of times people are like, oh, carbon, big deal, a little carbon in the atmosphere. But as I said before, the way that carbon accountants and greenhouse gas emissions reduction strategies measure, everything is measured in carbon dioxide from this list. It's all converted into carbon dioxide. So when scientists are talking about carbon, they're not just talking about carbon. So all these climate deniers that try to say that carbon, no big deal, you're wrong. So this is how we kind of measure these things. We have 3 categories, 3 scopes of measuring carbon dioxide, or of how carbon dioxide gets into the atmosphere, and these 3 scopes of how we measure it. And basically we have to quantify these things. So scope 1 right here, this is called stationary combustion equipment. So it's pretty easy. It's like your gas bill. A piece of stationary combustion equipment is your heating system. A heating system in a warehouse. Anything that's within the confines of a facility that burns fossil fuels. Scope 2 is electricity. So what's your power grid? What region are you in? Is it coal-fired? How does the electricity get to your house? Pretty easy to measure. We just take your electricity bill. Scope 3, however, that's the tricky one. So scope 3 is purchase goods and services from businesses. What do you need to make your little fidget spinner? How much metal and plastic goes into it? Transportation and distribution, how far was it shipped? The fuel and energy related activities it creates to make whatever you're making. Business travel for your employees to fly around. Employee commuting. How far do your employees have to get to work? Do they take the train? Do they take the bus? Do they drive? Do they ride their bikes? There's transportation and distribution of your product, use of sold products. How long do people use it before it ends up in a landfill? There's a ton of ways to measure scope 3. It's really, really difficult. There's a lot of overlap. There's a lot of double counting, and businesses need to communicate with each other to actually get accurate numbers. And we're not there yet, but hopefully soon enough, the SEC or different governments will start mandating these regulations. And in a lot of countries they have. In the United States they haven't, but there are voluntary compliance reporting standards. And essentially, if you are concerned about climate change, you shouldn't do business with a company that's not reporting. So, a lot of these companies, what they don't realize is like they face a lot of risk in their supply chains. There is an enormous amount of risk associated with the products that we purchase. We get things from halfway around the world. We get things shipped all over the place. We're running out of a lot of, precious metals or finite resources. And as we do that, we're destroying the environment because, as I said before, we're at this crossroads where we think we have to destroy the environment to make the economy work. But that's actually not the case, and I'll get into it here soon. And what we're seeing here is like, in 1980, we had like 3 natural disasters. Sorry, it skipped the slide and it won't let me go back. But I mean, you guys kind of saw the gist of it. As we got up to today, there's all these. Back then, it was like 3 natural disasters a year. Now we're having 2 a week. Really crazy. And, all of these severe weather storms, droughts, wildfires happening at a much more accelerated rate. So climate change is real. The proof's in the pudding. It's right there. And this slide right here is the planetary boundaries, which was created by the Stockholm Resilience Center. In 2009, they started measuring these things. And like we see here, basically there's 2, 3, 4, 5, 6, 7. So there's 9 planetary boundaries. I should have known that off the top of my head. And they range from like novel entities like plastics to stratospheric ozone depletion, atmospheric aerosol loading, ocean acidification, biogeochemical flows, land use change, freshwater extraction, and biodiversity loss, which ultimately results in climate change. So from 2009, we see these red areas where, these are the boundaries. If we stay in the green in the middle, we're kind of in the safe space, and then over here, it starts getting dangerous. And that means we're crossing these thresholds for a safe operating space for humanity to operate on Earth. 2009, 2015, we start to see more crossing of thresholds. 2023, we're seeing even more. And as of 2025, basically they're all surpassed except for stratospheric ozone depletion. And the reason stratospheric ozone depletion hasn't been exceeded is because of the Montreal Protocol, which banned a lot of HFCs and CFCs that were being leaked into the atmosphere as a result of a lot of refrigerants that were depleting the ozone layer. So a lot of people say like, oh, we used to hear all about the ozone layer, but we don't hear about it anymore. So climate change must not be real. They were wrong about that. Well, no, they passed the Montreal Protocol, banned these chemicals, and the ozone layer fixed itself. Super cool. It means that these treaties and international policies and protocols that we pass for climate resilience work. Ocean acidification has now surpassed the threshold. We are higher in ocean acidification, like 30%, than it's been in tens of millions of years. So we'll break down some of these kind of novel entities. What are novel entities? Well, novel means new. New things that we make, for instance, plastics. We have an insane amount of plastic production that is so harmful to the environment. Stratospheric ozone depletion got into it, atmospheric aerosol loading, so all of these gases that are leaking out into the atmosphere, biogeochemical flows. So like nitrogen, boom, phosphorus. So these are the fertilizers that we use. These are finite resources that we just keep extracting, which is insane because the way that farming operates today is like we take all of this biomass off of the farm instead of letting it go back into the soil and send it out to a landfill. And then it generates methane. And then we bottle up nitrogen and phosphorus in plastic bottles and send them back to the farm for people to use on monocultures that destroys the soil, and it gives you this like short-term solution that creates all these terrible implications over time. There's all this runoff from there that goes into recharging groundwater and underground reservoirs that this water then gets polluted. And we only have so much fresh water on Earth, so, and it's a tiny amount. Like there's about 2% of the water on Earth is fresh water, and only about 2% of that 2% is accessible. If you put it into a big ball, it would basically cover the size of Rhode Island for the entire Earth. And then land systems change, or land use changes. This is taking one type of land and converting it to another. So we take forests and we convert it to monoculture, crop, and farming. Or we take cities keep expanding and expanding and expanding, and we're taking those natural areas and turning them into urban areas. The way that we're abusing land is we're a member of the community of land, and when we start abusing it and treating it like shit, what do you think is going to happen? All of these animals and creatures that live there, we start seeing genetic biodiversity loss and functional biodiversity loss, where we're seeing the amount of animals that are going extinct, plant species, insect species, happening faster than scientists can even begin to try to count them. And then, we're seeing this massive die-off of insects right now, which is totally frightening, because an Earth with no insects, if there were no insects, all of the plants would die. There would be this huge fungal bloom that would consume everything. The fungi would die off, and we'd be back. It would set the planet Earth back about 1 billion years in the course of 2 years, back to just single-cell organism algae. And all of these things going around the big circle lead to climate change. They all release CO2 into the atmosphere, and this radiative forcing of the greenhouse gas effect, where solar radiation comes into the Earth but can't escape, exacerbates. So this climate change isn't just CO2. This is what I'm getting at. Climate change is the result of all of these different things I just explained. And it's not just carbon, guys. So yeah, we've got the carbon cycle here. And carbon, the Earth is this closed loop system that keeps pushing things around, and it naturally self-regulates. But when we start going in there and messing everything up, these cycles get thrown off. So, we have carbon dioxide in the atmosphere, and then it goes up here, and then, it shoots down into the ocean, because the ocean is this huge carbon sink shred. And then it uplifts and goes onto land, and microbes goes into the soil. Microbes start doing all this cool stuff and sending it into plants that photosynthesize, and goes into animals, and there's all this respiration that sends it back in the atmosphere. But the big thing here is human emissions. We are pumping out way more than these natural cycles here and here ever do. And there's other cycles, there's the water cycle, which the carbon cycle massively affects, because, healthy soil that's full of carbon, there's a ton of water infiltration into the soil that percolates down into the bedrock, and then this groundwater flow goes out to the ocean and mixes, and then there's precipitation that goes up from the ocean to make clouds, and then it comes back over and it rains, and, water is just constantly flowing through the environment. And the more water that flows through the environment in a healthy way, it has this symbiotic relationship with carbon that creates this healthy ecosystems. And then we have the nitrogen cycle. So nitrogen is a finite resource, and essentially, a lot of it comes down to nitrogen fixation by bacteria. So bacteria in the soil, there's this cool trade-off where the nitrogen in the plants, so they're in the microbes, and then they trade a little bit of sugar through the root rhizomes from plant to microbe. So microbes here, I'll give you a little nitrogen, you hook me up with a little sugar. And nitrogen gets fixed into the soil. But what we're seeing now is with all these agricultural practices, they are taking nitrogen from faraway places, putting in a plastic container, going to the farm and, adding all this nitrogen. And then the plants are cool, I got this nitrogen boost right now, but it's depleting the soil in the process. So they're constantly having to be fed by human intervention rather than doing it in a regenerative way, where you're increase the carbon in the soil, which fixes the nitrogen into the soil. So there's a natural way to do this, and now we're seeing all of this runoff out into the ocean of nitrogen that further acidifies the ocean and that drives climate change. And same thing with the phosphorus cycle. Phosphorus is another finite material. It's a soluble mineral. Sorry, it doesn't turn into a gas, so like it's hard for it to get back into the atmosphere, but there's a ton of runoff and leaching, which leads to polluting groundwater, and it's harmful to aquatic life in the ocean. So essentially what I'm getting at is like we need to keep ecosystems intact, and this idea that intact ecosystems can provide us with everything we need, rather than this idea that we're have to destroy the environment to make the economy run, is just this like totally insane idea. So these are all of the benefits from nature, from intact ecosystems. These are called ecosystem services. So they provide 4 types. They're provisioning ecosystem services, regulating, supporting, and cultural. So provisioning is like things that we can get from nature. We can get materials, we can get water supply, we can get natural medicines, we can get renewable energy sources, food and drinks. All of these things come from nature. And what we need to understand is that the entire economy is subsidized by nature. I'll say that again. The entire economy is subsidized by nature. And what is nature subsidized by? Nature is subsidized by the soil. Everything in nature grows from the soil. So therefore, our entire economy is subsidized by the soil, and we're out here just destroying soil. Desertification of soil is happening at stupendous rates. It's terrifying, and like we really need to focus on soil. And then we get all these other ecosystem services, regulating ecosystem services. So these are pollinators roaming around and pollinating plants and doing their thing, which they create these natural pest controls for instead of spraying all of these crazy pesticides, and we're killing off all of the insects. And you used to drive and you'd get all these insects that hit your windshield. Like that doesn't happen anymore, because there's a couple billion insects for every human being on Earth, and the rate at which they're dying off is like crazy. And if they die off, like we got in 2 years we'd be set back 1 billion years. And carbon storage, flood management, so like mangrove forests, for example, flood management. We build all these levees and dams, knock down these mangrove forests, but mangrove forests naturally control floods, erosion control from healthy soils, blah, blah, blah. Supporting ecosystem services. So these are the ecosystem services that support healthy ecosystems. Nutrient cycling, we just got into that with nitrogen and phosphorus. Or space for wildlife. This is, biodiversity. We need to keep biodiversity intact. Healthy soils. Already expressed the importance of that, and healthy soils create more photosynthesis, which increases nutrient cycling. Like all of this stuff is tied together, and we need to understand that we're part of this entirely like complex web of life, and we want to break down nature into these separate parts. It's not. Nature is this insane system that everything works together. And when we start isolating nature into these individual silos and thinking that we can destroy one thing and it's not going to impact everything else, is nuts. And then nature is cool because we get all these cultural services from it. Tourism, we can go to nice places, and we have these inspirations that come from nature. Ralph Waldo Emerson, or Henry David Thoreau, or Aldo Leopold, like the greatest writers. Their inspiration comes from nature. Recreation, we can go out into nature and enjoy it, and that gives us a sense of place and a sense of purpose. And one of the issues that I see is like, people are just flying around all over the place for like tourism, and being like posting it on their Instagram, like, oh man, I'm living my best life. But like, are you? one flight from Washington, D.C. to Florida, like a 2-hour flight, for every single person on the plane, it generates more emissions than a person in India generates in their entire lifetime. So, like, can't we have these cultural experiences in nature that are closer to us? Can we just, like, kind of enjoy the spaces where we're at? I mean, I got a beach right down the street. Why do I need to fly to Bali to go to the beach? Yeah, sure, it's not as nice, but, like, we live in this culture of opportunists and sensationalists where people just constantly need to be feeling some type of sensation to be alive, rather than just, like, sitting with their own thoughts. And when we can live within our means and sit within our own thoughts, maybe we can live a more humble, meeker life. And yeah, that's not sexy for Instagram, but, like, it's kind of what we need to do. And I think that there's a lot of integrity in living that kind of lifestyle. So, we need to be more aware of our carbon emissions. And people want to blame, corporations, but I still shop on Amazon. I do. Like, who am I going to point the finger at? It's impossible to necessarily, like, live a life without fossil fuels, but we can reduce the amount of fossil fuels that we use. And I don't know. I guess I'm kind of rambling now, but, like, we need to be aware of our carbon footprint, essentially, and we all play a role in this. And a lot of people want to blame, corporations. They want to blame other countries as well. A lot of, right-wing Americans are like, China's polluting everywhere, but per capita, China has a lot more people than we do, and on a per capita basis, they don't pollute nearly as much as an American does. An American consumes more calories per day than a sperm whale, the largest animal on Earth. And not just food calories, this is the electricity that we use, our heating systems, our refrigerants, whatever else we use to make our life a little easier. So, like, at the end of the day, there's not too many people on Earth. There are too many Americans. There are too many people living this lifestyle of sensationalism and signals of wealth and affluence, and the identifiers of success being that, oh, I have gone on 12 different vacations this year. It's like, well, at the expense of who? At the expense of the future, at the expense of poor people. And that's not cool. So, like, I think what we signal as success today is, success in human terms. It's success in the sense that nature is at odds with our economy. And yeah, you're doing a great job if you're doing that. But the new cool is, like, chilling the fuck out and sitting with yourself and being one with nature and being part of this greater system, and just realizing you're just one small cog in the wheel, but you have a huge, tremendous, enormous amount of impact by living in a way that is healthy and aligned with the integrity of keeping ecosystems intact, and the idea that keeping ecosystems intact might save us is a miracle. So thank you for listening today, and I'll see you guys soon.